All right, folks, it's Jean Adams from Flamingo Math. We're in our last day on lesson 310. Today's the day that we'll solve trigonometric inequalities. Example 10 asks us to find an interval that will satisfy the inequality cosine 2x is greater than 0. The first thing I want to do is think about where is the cosine of 1x 0, and we know that cosine of x is 0 at pi over 2, up here at pi over 2, and at where? Negative pi over 2 or 3 pi over 2. We can solve the double angle 2x is greater than pi over 2 plus 2 pi k, and we can also solve 2x is greater than 3 pi over 2 plus 2 pi k. So that will give us two different intervals. X is greater than pi over 4 plus pi k, and this one x is greater than 3 pi over 4 plus pi k. The next thing I want to do is I want to draw a number line and use that number line to test some values. So this is going to be our test strip. We're testing from 0 to 2 pi, and we have, for this set, we've got pi over 4, and then we have 3 pi over 4. If you put a 1 in here for the k, that's 1 1/4, so that's 5 pi over 4. If you put a 1 here, that's 7 pi over 4. And after that, we're beyond our domain. So testing those intervals, we want to test intervals for the cosine of 2x. And what I'm going to do is I'm going to pick a number between 0 and pi over 4 and substitute in there. So I'm thinking at pi over 4, thinking of it this way, pi over 4 is here. Everything's positive up there, so this is a positive interval. And between pi over 4 and 3 pi over 4, so we've got some positive values and some negative, so this is going to be negative. And then between 3 pi over 4 and 5 pi over 4, I've got another positive value. And 5 pi over 4 to 7 pi over 4, that's going to be negative in here. And then the last one would be positive when we get to 2 pi. That gives us a good glimpse at how to answer the question. So cosine of 2x is greater than 0 on 0 to pi over 4 and 3 pi over 4 to 5 pi over 4, and the last interval from 7 pi over 4 to 2 pi. So this was true, this was false, this was true, this was false, and this was true. So we have all of our solution intervals right there. Let's go to example 11. In this one, we're solving sine of the quantity x minus 3 has to be greater than or equal to the sine of x. I think the best way to attack this one would be to sketch a graph here between 1 and -1. So give me a minute to put those together. We want a sketch of those. You can graph that with your calculator if you'd like. So take a look at my graph here. We've got this function is our sine curve that goes from 0 to 2 pi. That's the right side. And the left side starts at -1. It's shifted over at pi over 3, which makes this our sine curve shifted over. It terminates at 7 pi over 3. And they're asking us, where is the sine of x minus pi over 3 greater or above the sine? So this is above the sine curve in this section here. What's our problem? we need this point for an intersection point. We need to know that value. This is going to be x sub 1, and we need to know that value, x sub 2. So we can do that on our calculator, and on the interval from 0 to 2 pi, we're looking where the first graph, that first graph, I'm going to call this one the f of x. So I want to know where f is. If this is f of x, I want to know where f of x is greater than or equal to g of x. This is g of x. So we can find that x sub 1 using the intersect feature. That x sub 1 point is at 2.09, 0.866, and the x sub 2 intersection point is 5.24 and negative 0.866. Therefore, we know our interval goes f is greater than g on 2.09 to 5.24 inclusively. Okay, here we go on number 12. We want cosine of x plus a third has to be greater than or equal to 0 on the interval from 0 to 2 pi. This is my endpoint at 2 pi, and we've shifted our graph up a third. So instead of this being 0, 1, it's 0, 1/3, 1 and 1/3. And we want to know the zeros. Where is this and where is this? This would be my x sub 1, and this would be my x sub 2. And we're looking for where the graph is above the x-axis. So thinking about that, I want this interval here, the function's above the x-axis, and this interval here, and I see my intersection points are at intersection. Let's see, we want to erase that. My intersection point is at 1.910, and the next intersection point is 4.370. So to make that statement true, the cosine x plus a third is greater than 0 on the interval from 0 to 1.91, 0 to 1.91, and from 4.37 to 2 pi. So this is the two intervals that makes that statement true. Okay, let's jump into example 13. We want to solve the inequality 4 times the absolute value of tangent x is minus 1 is less than 0. I'm going to attack this one a little bit differently. If we take the tangent of x, absolute value, and add 1 to both sides, divide by 4, I can graph y1 is the tan of x, absolute value, and I could graph y2 is 1/4. And we want to know where is the tangent. This is f, and this is g. I want to know where is the tangent graph, f of x, less than the g of x graph. And you can tell I've got it highlighted here. It's going to be in this section from 0 to something, and then it's going to be in this section from something to pi, since they've asked us to stop at pi. We're going to call this point x sub 1, and we're going to call this point x sub 2. So the intersection x sub 1, using our graphing calculator, is at 0.245, and x sub 2 is about 2.896. The intervals for our solution would be from 0 to 0.245, and notice it's just less than, not equal to, so we've got open parentheses, and then finally from 2.896 over to pi, open parentheses. So these aren't so bad. You just have to be careful with the graphing and reading. Here's an application problem. When you're breathing, a normal cycle takes place about every 5 seconds. The velocity of airflow y, measured in liters per second, after x seconds is modeled by this equation y. Velocity of airflow is positive when we inhale, and it's negative when we exhale. For one cycle of breathing, we want to find an interval of time where the function that they gave us is greater than 3/10. So first, let's graph that with our calculator and take a look at the two equations. We want first the equation 0.6 sine. No, I think I want to do this. I want to divide the 0.6 out. No, that would be okay. 0.6 sine of 2 pi over 5x. So on our calculator, we got, this is our graph, and we want to have a graph of y equals 0.13. So on the left-hand side, we graphed this equation on the left, and this equation on the right, we graphed as a separate line, 0.3. So this is the f of x, and I want that to be greater than the g of x. So g of x is 0.3. Where is it greater? We need to know here and here, because we're looking for the region here. This region is the true part. So how are we going to do that? We've got sine. Let's see, I guess I could use some algebra. Let's say the sine of 2 pi over 5 is greater than or equal to 0.3 divided by 0.6 is a half. Where is sine a half? That happens at pi over 6, so 2 pi over 5x is greater than or equal to pi over 6, multiply by 5, divide by 2. We have what? 5 over 12? 5 over 12. We also have 2 pi over 5x is greater than or equal to 5 pi over 6, because in both of those cases, thinking of the unit circle, sine is 1/2 at pi over 6 and at 5 pi over 6. Multiplying by 5, dividing by 2, so 25. The pi's cancel out, divided by 6 times 2, that's 12. So we found this solution is 5 over 12, and this is 25 over 12. So our interval, therefore, our interval inclusive is 5 over 12 to 25 over 12. And what does that mean? On that interval from 5/12 to 25/12, you are inhaling, because they told us it was positive, you are inhaling at a rate of at least 3/10 of a liter per second of air. And I believe if you checked these values here into our equation, you would get that the amount of air is like 4.4166 to 2.0833, I believe, is the amount of air. So it's more than a third of a liter per second. Okay, last question for this lesson. The number of hours of daylight on campus at Harvard University is given by this big, ugly equation. We want to find the interval where Harvard University will have no more than 10 hours of daylight within a year. Do you hear that inequality? No more than 10 hours of daylight. Looking at that equation on a graphing calculator, we have got to go out to 365 days here, and you have to scoot up to 12 because 12 is my shift up, y equals 12, or is that y equals 10, I'm sorry. We've got the graph here and here. So this is y equals 10. We're looking for those two intersection points. So x sub 1 and x sub 2. We went all the way out on x to 365 for the year. And what happens? We're looking at this x sub 1 is about 37, and x sub 2 is about 304. So if you want to go in days where no more than, we're going to look at this area. So no more than 10 hours and no more than 10 hours. We're looking for those areas. So that would be calculating 37 days, January the 1st to February the 7th, no more than, so inclusively, and October 31st to December 31st, inclusively. And lastly, we want to find the interval where the campus will have more than 14 hours of daylight within a year, which means we're solving for y greater than 14. So using the same equation, just moving that line up and moving our intersection point. So we've got the same deal here for 365 days, but now our line is at y equals 14, and we're looking for that intersection above. So what would that give us? Y equals 14. So we want these two intersection points, x1 and x2. So x1 is day 122, 121.4. Is about 121.4. I'm going to round that to the next day. And day 2 is 219.1, so we'll leave that at 219. And calculating off my calendar, May the 2nd would be day 122 up to August the 7th, I'm sorry, would be the end of the other one. So these would not be brackets. I got that wrong. We want parentheses because it's not inclusive. May the 2nd to August the 7th. And we've got the days are on a year with 365 days for the year. So that's the conclusion of lesson 3.10 on trig equations and inequalities.